In this video, we're going to have a conversation about three possibilities for solution sets of systems of linear equations. And these three types of solution sets are here addressed with case studies or specific illustrations. So we consider an augmented matrix. This is an illustration. This is applicable for scenarios with a lot more equations or unknowns, but for purposes of illustration, let's talk about one of the three types of solution sets. That would be the set that contains nothing in it. So when a system has no solutions, a system of linear equations without solutions, that's what SLE stands for. That means that its solution set is the empty set. And that is something we can infer from the reduced row echelon form, the so-called RREF. That's what we're reading here. The first row of this RREF tells us that we're reading each row. So remember, some of those values are coefficients of the unknowns, and the value in the last column, which is a 0, is the value is going to be in the right-hand side of the equal sign. So here we would write 1x1, 0x2, 1x3 minus 1x4. That's equal to 0. That's no problem. There is an equation. The second row tells us that we have 0x1, 1x2, 0x3, 0x4, and that is equal to 0. And then the last row, there's also no problem with that equation. The last row, it tells us that we have 0, x1, 0, x2, 0, x3, 0, x4. So everything to the left of the last column is 0, 0 plus, 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 and then this is equated to 1. So this is implying that the left-hand side is 0, and the right-hand side is 1, and this is implying 0 equals 1. This is a so-called contradiction. So in mathematics, we use these two arrows kind of facing each other. There is a face-off. This is a so-called contradiction. This contradiction is a red flag that we can infer from the information provided by the reduced row echelon form. So when there is a contradiction, something that is equal to something that is not equal to, they're not supposed to be equal to, then we rule out it is not possible to find solutions for this system. This would be one of the scenarios where the solution set is the empty set. The second, case study 2 out of 3, the second type of solution set we're going to discuss is one for where one corresponding to a system that has one solution only. This is the so-called unique solution. And the pattern, again, this is illustrated for this scenario, but this is generalizable for scenarios with more equations and more unknowns. The pattern is that the reduced row echelon form, remember those vectors we call the standard unit vectors? Here they are, they appear here. E sub 1, you have 1, 0, 0. E sub 2, 0, 1, 0. E sub 3, 0, 0, 1. So those standard unit vectors are part of the REF. That would be a good, instead of saying red flag is for when something is bad, this is a good flag. I don't know, white flag or something like that. I don't know. So then for what we read from every row, we have in the first row 1x1, 0x2, 0x3, that equals -3. The second row tells us 0x1, 1x2, 0x3 equals 5. The last row tells us 0x1, 0x2, and 1x3. Excuse me. And so this equation is equal to 2. So from each of these equations, basically we obtain here x1 equals -3. That's why we deduce on the first equation. The second equation becomes x2 equals 5. And the last equation gives us x3 equals 2. Okay, so this is a unique solution. So the third type of solution set is one in which the system supports not just one solution, but in fact many solutions, as many as infinity of solutions, if you will. So from the first row, this RDF tells us that we have an equation, looks like 1x1, 0x2, 3x3 minus 2x4 equals 4. The second row tells us 0x1, 1x2 plus 1x3 minus 3x4 equals 0. Either of both of those equations are fine. There is nothing unusual. There is no contradiction. Then here, row 3 is implying that we have 0x1, 0x2, 0x3, 0x4, okay, on the left side, and then the right hand side, this is equal to 0. So this equation is simply saying 0 equals 0. This is totally fine. Those are two things that are supposed to be equal to one another. There's no contradiction. One thing to note here is that not all the columns, but some of the columns are standard unit vectors. That's the case for the first column. That would be the case here for the second column, okay? But not all columns are standard unit vectors. So basically, if we are keeping track of the staircase, so here we have 1, 1, and then we kind of have a messed up staircase with only 2 stairs or 2 steps, right? And it's because we have a row of zeros. In cases where you have a lot more rows, we may have several rows of zeros. Since there is no contradiction, there is nothing wrong with that. It's just for us to realize that the pattern here is telling us that this would be a scenario in which we would have infinitely many solutions. And just towards the end of this video, a little note about inconsistency. That would be the other word, inconsistency. This means no solutions, okay? And so we are interested in a scenario for which we can argue that there are no solutions or some values of most of what we see here are things we're familiar with. We see variables and we see coefficients, integer values as coefficients, but there is one location where the coefficient is not an integer, is denoted with the letter k here. That k is called a parameter. So what we'd like to do, so the hints for this type of problem is we're going to do exactly what we had described before. Form an augmented matrix, write the system in matrix vector form, form an augmented matrix, and compute the reduced echelon form. This is a fairly simple. The augmented matrix here would have 2 rows and 3 columns. You'll have to do a few steps. But remember, reduced echelon form is something that requires you to create ones and zeros, and from that you will be able to determine a condition for the parameter k for which there are no solutions.